So we're moving on to number 2. It says, from the following diagrams, list which ones are functions and which are not. And B, write down which diagrams represent one-to-one, many-to-one, one-to-many, and many-to-many. So part A says, list which ones are functions and which are not. So we have to define what is a function. We have to get the definition of a function. And we can get that in module 9. A function is a mapping whereby each domain, each x, which are on the horizontal axis, maps onto only one range, which are the y's, which are on the vertical axis. In other words, each x value has only one y value. Okay? So let's start with the D. Let's start with this one to see if this is a function. Now, close inspection, you can choose any x. You can choose any x. Let's choose 1. Let's choose 1. Remember, the x is on the horizontal axis, so let's choose 1. For example, 1, look 1 there, right? The x equal 1. And let us see now if it follows this rule. It's supposed to be a function, that 1, which is an x, supposed to map onto only one y. But close inspection, you can actually see that if you start from this x there, it has a y up there. It has a y up there. Here it is. Okay. Can bring it across. It has a y up there. Yes. But again, it also has another y down there. So this now is violating the rule for a function. A function says each x must have only one y, but look at an x with more than one y. It has one up there and one down there. So clearly, this mapping, this graph, this mapping is not a function, because look at an x with 1, 2 y's. So clearly, this is not a function. It is not a function, because we have found an x. 1 alone suffices. We have found an x with more than 1 y's. And as the rule said, to be a function, each x must have only one y. That's very important. Only one y. Okay, to be a function. Each x must have only one y. Each x, only one y. And we have found an x with more than one y, so this is not a function. Let's check out E to see if E is a function. As seen, this x there, let's say 2, has only one y. And if you follow the pattern, that appears to be the case for all the x's. Each of them have only one y. So clearly, E is a function. So because each x for E has only one y, E is a function. So we're going to test to see if f is a function. So we choose x equal 4. This is 1, 2, 3, 4 for x equal 4. So we test to see how many y's does x equal 4 have. X equal 4 have a y of 3 and also maps onto a y of -3. So 4 maps onto 2 y's. Now remember, we say to be a function, each x must map onto only one y to be a function. So if here x equal 4 mapping to 2 y's, which is more than 1, it maps onto 3 and -3. So clearly f is not a function. So here the only function is e, because each x maps only to one y for e. Now the question goes on to say, write down which diagram represent a one-to-one, a many-to-one, a one-to-many, or many-to-many. What mapping? So as you can see, each x maps onto more than one y. So one going to many, all right? Because that one they're going to 2, all right? Plus, if you go across, you've seen that if you choose a y, let's choose a y of 3, for example, you will notice that it has more than one x's. So a y of 3 has more than one x's, and each x has more than one y's. So clearly, this is a many-to-many. Look at 3. 3 goes to 3 and -3 also. 1 goes to almost 4 and -4. So this is a many-to-many mapping. These are many-to-many. Now, as you can see, -2 goes on to, let's say, 2.1, and 2 goes on to 2.1 also. So many going to 1. You see it? Many going to 1. You see how the conversion 2 goes there and goes across, meets there. -2, which is another x, go up and go across, and they meeting here also. Both -2 and 2 meeting at the same place, so many going to 1. So that's a many-to-1 mapping. It's a many-to-1 function. So in conclusion, E is a many-to-1 mapping. Let's move on to F. Now, as you can see, 4 is going to 2. 1 is going to many. You see that? 1, 4 going to many. 3 going to many. Same thing with 3. 3 is also going to many. So 1 is going to many. So let's use 3 as another example. 3 is going to 2, and you can also see 3 is mapping onto -2 also. So 1, 3 is mapping onto both 2 and -2. 1 is going to many. So F is a one-to-many mapping. So in conclusion, F is a one-to-many mapping. So you have a many-to-many mapping. Here you have a many going to 1, many x's going to 1y. You see? Many x's For here you have many x's going to many y's. That's the many to many. Here you have many x's going to one y. So that's a many to one. And here you have one x going to many y's. So that's a one to many.